Okay, hi and welcome back to this video series on the Comptia Security Plus course, Job Rotation. This is one of the checks and balances that might be employed to enforce the proper separation of duties. Job rotation is when users are cycled through various assignments to increase user insight to an overall operations, reduce employee boredom, enhance employee skill level, increase operation security. By incorporating the implicit deny, least privilege, separation of duties and job rotation concepts, your total access control plan can be improved greatly. These access control principles can be applied both to desktop computers and to mobile devices. However, the specific way they are applied will depend on the particular operating systems and the policies, both written and computerized, of the organization you work for, rights, permissions and policies. Now that we have a plan for access control, we need to implement it in a tangible way by strategically setting up organizational units, users, groups, and by assigning permissions according to our chosen access control model. We can create a safe, guarded working area for all employees. In doing so, we can protect the data on the network. User groups and permissions. User accounts can be added to individual computers or to networks. For example, a Windows client Linux computer or Mac can have multiple users. Larger networks that have a controlling server, for example a Windows domain controller, enable user accounts that can access one or more computers on the domain. In a Microsoft domain, users are added in Active Directory users and computers ADUC as shown in figure 11.3. ADUC can be accessed from administrative tools or added as a snap-in to an MMC. Users can be added in one of two places: in the users folder. This is located inside the domain name within ADUC. In an OU, organizational units can be created within a domain controller. These are often made to mimic the departments of a company. In figure 11.3 there are accounting and marketing OUs. Users can be created within these OUs. User rights can be modified within the particular user's properties window. There are many more rights associated with a user account that is stored on a Windows Server domain controller than there are on an individual Windows client computer. For example, the account tab can be configured so that the user account has an expiration date. You can see this in figure 11.4, where at the bottom of the properties window we have configured Alice's account to expire on April 1st 2020, and that was no April Fool's prank. Immediately after the expiration date, the users log in to the domain unless her account was reconfigured or she logged in as someone else. By clicking on the log on hours button, time of day restrictions can be configured so that a user can log on only at certain times throughout the week. An example of this is shown in figure 11.15. In the figure, Alice's user account can be configured in such a way that she can log on to the domain only between 8 AM and 6 PM Monday through Friday. If she attempts to log on at any other time, the system will deny access. These kind of access rights are available on domain controllers. Sometimes users have more than one account. This might have been done to allow access to multiple systems or resources. There are plenty of different issues that can occur because of this. To mitigate problems that can develop from a user having two accounts, consider the consolidation of accounts. For example, utilizing a federated identity management (FIM) system, one that will incorporate single sign-on SSO. User administration can also benefit from credential management, where passwords, certificates and other logon credentials are stored in a special folder called a vault. A security administrator should also consider the use of roles, RBAC and user groups. Groups can be created to classify users and to ease administration when assigning permissions. If you refer to figure 11.3, you can see that a group is displayed with a two-headed icon. For example, the domain admins group. Single users are displayed with a single head, as in the case with the administrator. By grouping users together, you can save a lot of time when assigning permissions to files and other resources. Instead of assigning permissions to one user at a time, it can be done to the entire group in one shot. Permissions such as file and printer access can be assigned to individual users or to groups. These permissions are also known as access modes. For example, are examples of access control lists, ACL specifically. File system access control lists, abbreviated as FACL or FSACL. An ACL is a list of permissions attached to an object. ACLs reside on firewalls, routers, and computers. Permissions in an ACL might allow access or deny access. It all depends on who is required to have access. Then the configuration is up to you. In Windows, there are two types of permissions. Sharing permissions are basic permissions, including full control, change and read, which are applied to folders only. These are often ignored in favor of the more powerful superseding NTFS permissions, also called security permissions, which can create folders and individual files in a standard Windows folder on a domain. The types of NTFS permissions include the following: full control, modify, read and execute, list folder contents, read, write. These are shown in figure 11.6 on a Windows server in the properties window of a folder named test folder. Note that the administrators group has full control of the folder. Also note that you can allow particular permissions or specifically deny those permissions. If a permission is set to allow, it will be implicitly denied. In Linux, file permissions are broken down into three types: read, write and execute, or W and X. They can be assigned to three different permission groups: owner, group and all users, U, G and O or A. These can be assigned and configured in the command line with the chmod command. Change mode either by group letter or by using a designated numbering system. For example, in the latter case, R read equals 4, R W write equals 2, X execute equals 1. These are added together to form each permission. For example, if a user was given read and write access, the number would be 6. If, however, the person was given read, write and execute command, the number would be 7. Here's an example of the chmod command: chmod 760 test file. In the example, we have the chmod command followed by the numbers 7, 6 and 0 and name of the file, test file. Of course, the path to that file can be more complex. The first number 7 represents the owner permission, which in the case is equal to full access. The second number 6 represents the group permission, in this case read and write access. The final number 0 represents all the users or all the users permission, which has no access. This is just an example. The numbers could be whatever you select for the three groups. You might see 777 when all groups have all permissions, though it is not normally recommended. It is common on a web server or a file server to see 755, which means that the owner has all permissions and the group and all users have read and execute permissions. You don't want a typical user to have write permissions on a web server. In summary, the chmod command is a great way to assign permissions to all three groups using a single command. To avoid access violations when working with permissions, the least privilege or minimum privilege concept should be implemented. Give the users only the amount of access that they absolutely need. Note that permissions for long-term employees could suffer from privilege creep over time. To mitigate this, consider periodic user permission reviews and evaluation of ACLs. This permission auditing procedure will ensure that users have the access to the correct data. In general, this is known as user access recertification. Consider this procedure if a company has a particular high attrition rate, hiring and terminating of employees. This will verify that users no longer with the company cannot log onto the network and cannot gain access to resources. It also ensures that new users gain access to necessary resources. Permission inheritance and propagation. If you create a folder, the default action it takes is to inherit permissions from the parent folder, which ultimately come from the root folder. So any permissions set in the parent are inherited by the subfolder. To view an example of this, locate any folder within an NTFS volume besides the root folder, right click it and select properties, access the security tab and click the advanced button. That brings up a window as shown in figure 1117. If you look at the bottom of the figure, you can tell whether or not the folder is inheriting permissions from the parent. In this case, it is inheriting permissions. This means that any permissions added or removed in the parent folder will also be added or removed in the current folder. In addition, those permissions inherited cannot be modified in the current folder. To make modifications, you would have to disable inheritance either by clicking the button as shown in figure 1117 or by deselecting the checkbox on older versions of Windows Server. When you do so, you have the option to copy the permissions from the parent to the current folder or remove them entirely. To summarize, by default, the parent is automatically propagating permissions to the subfolder, and the subfolder is inheriting its permission from the parent. You can also propagate permission changes to subfolders not inheriting from the current folder. To do so, select the Replace All Child Object Permission Entries checkbox. This might all seem a bit confusing and you will probably not be asked many questions on the subject. Just remember that folders automatically inherit from the parent unless you turn off inheriting, and you can propagate permission entries to subfolders at any time by selecting the replace option. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.